we're starting with today's 5.3. This is an extended one. It's relate arithmetic sequences to linear functions. I did add something on mine that you won't see on your individual one, but if you end up going to my content library, to my example, you can copy this little kind of little anchor chart thing I end up putting on mine. First thing is, we're just looking at normal sequence of numbers, and we have to find out what the pattern is. So it says, find the next two numbers in the pattern. So it went 6, 13, 27, 6, 13, 20, 27, 34. What is our next two numbers?
41 and 48.
Okay, 41 and 48. And how did you find that? What is our pattern?
It just plus 7 every time.
Okay, so one thing we can look when we have our sequence of numbers, we look, what's the difference in between the number pattern? Well, it was going up by 7. It was going up by 7. It was going up by 7. We had the constant pattern. So when they ask us for the next two, it's just simple. I add 7 to the last one, I get my answer, and then I add 7 to that. Okay? Let's look at number 2. 2, 3, 5, 8, 12. What's the next number? What did you get? 17. How did you get 17? So 1, then 2, then 3, then 4. So we're going to add 5. So this time we need to add 6. So our next number is 23. Okay. Let's go to number 3. 54, 43, 32, 21. Rob? What did you get after 21?
10. Isn't it 0? No. It's 10 and then divided by 11. Yeah.
Oh, geez. I can't subtract. I was like, no, why are you getting that? I'm doing the subtraction in my head. No. So, when it's going down, actually a good thing to do when it's going down is I should have done my work on the side. Go ahead and do 54 to 43, and what's the difference? Was 11. I'm not gonna lie, when I was first looking at it, I was thinking it was 9. Definitely putting that stuff away so you can be following along with our notes. So we subtract 11 from 21 and we get 10. What about our next number? 10 minus 11 would give us okay, not too bad. And the last one, negative 5 to negative 2 to 1 to 4 to 7. Our next numbers are 10 and 13. Good. 10, 13 because we are adding 3 on each one. Okay. Today our learning goal is that I can understand how mathematical ideals build on one another, and I can use representations to communicate mathematical ideas. Hey. My picture didn't stay, I don't think. Oh yeah, that did. Okay. So, not much we have to look at this, but we're just going to explain this. It says, a sequence is an order of list. I can't even read. A sequence is an ordered list of numbers. The numbers in a sequence are called terms. In a rhythmic sequence, the difference between consecutive terms is consistent or constant, if I could read. There's a reason I teach math. The constant difference is called the common difference. An arithmetic sequence has the form A1, then A1 plus D, then A1 plus 2D, where A1 is the first term and D is the common difference. For instance, if A1 was 2 and the difference was 6, the sequence would be 2, 2 plus 6, 2 plus 2 times 6. Or if we were to figure this out, it's like they gave us the equation or the sequence. They said 2, 8, and 14, and they're asking us what comes next. Well, you guys would be able to realize that between 2 and 8, the difference was 6. So you just say 6. And then you would say from 8 to 14 was 6. But the reason we want to know about this equation on how we use it is because if I would ask you what the 56th number is, do you really want to go out and work it 56 times? Or is there a way that we can use an equation to help find that final answer? So that's what we're going to kind of find out today. So identify an arithmetic sequence. Tell whether the sequence is arithmetic. If it is, find the next 2 terms. So if it's arithmetic, what is that going to mean to me again? Thank you. It's going to have a consistent pattern. It's going on by the same thing. So if you look at A, do we have a consistent pattern? Yes. I'm hearing yes. What's the pattern? What is, even if I read it here, what is the D, the consistent rate? Evelyn? +5. Okay, so we're going to be adding our 5. So -4 plus 5 is 1. Plus 5 is 6. 6 plus 5 is 11, and so on. So yes, what are my next 2 terms then? 21 and 26. Pretty good. How about for B? Three, 5, 9, 15, 23. Zoe? Oh, so I'm hearing you. Okay, why did you not think it is? Okay, so it kind of went off from the end. Rahab?
I think it's 2, 4, 6, 8.
So is there going to be a consistent, Maddie?
I don't think so because it keeps going up. So then depending on like what number you're on, like it's kind of hard to like, tell like how much you're like adding or not.
Okay. Alex?
I think it'll be the same because it's gonna keep going up. The slope's gonna get like steeper, but it's gonna keep like adding 2 on the
What did you say there? The what's going to get steeper? The what?
The slope.
Where's the slope at?
Well, the rate that the numbers like get higher.
So we can start relating this to graphing, right? Okay. So it sounds like this one's tripping us up. Let's leave this one for a second and we'll come back. So in this example 2, it's saying graph a sequence. We're already talking about slope now. So it says the sequence is -4, 1, 6, 11, and 16. So if we have to graph our sequence, what they're asking us to do is first we're going to make a table pairing each term with its position number. And so when we make this, we have our domain, our x, which is position, and the y is the term. So, position. Position means where is it lying? Is it the first term? Is it the second term? So that one's pretty easy. We have first, second, third, fourth, and fifth. And I was talking to, I believe, with Maddie earlier today when we were looking at our review, and we were talking about understanding which term is x and which one's y. Remember, when we do a graph, typically when we're looking at our x and y's, our y is our total amount of something, and your x is the number of them. So like, if we were graphing how much snow has fallen in the last 5 days, your x-coordinate is the days. Day 1, day 2, day 3, day 4, day 5. And your y-coordinate is that total amount. We had 13 inches. We had 26 inches. We have a lot of snow there. So y is usually our total, and then x is our individuals counting up. When we look at here, we're looking at the same thing. Our position is x. These are going to be our individual ones. 1, 2, 3, 4, 5. And then term is going to be our total, what came out. Our terms are going to match up with right here. So our first term was -4. Then we had 1. Then we had 6. Then we had 11. Then we had 16. There's a couple things we could look at now. We want to plot the pairs on the table as the points in the coordinate plane. Well, that's easy because now I have coordinates 1, -4. I have 2 and 1. I have 3 and 6. 4 and 11. And 5 and 16, which I think on this graph we're not going to get to all of them. But I'm going to zoom in on my screen a little. So let's do 1, -4. So I go over 1 and I go down to -4. Then we do 2, 1. And then we do 3, 6. And then we do 4, 11. Okay, that might be the last one I did. Because there's 10, it's got to be somewhere up in here. Okay, so if I did this correct, and then I draw my line. Yep. Hard when I'm blocking myself. Can't move it at all. Wouldn't it be better for me to use another tool? There we go. So much better in my drawing. Okay, so did this make this sequence of events, did it make our linear graph? Did it make a straight line? Yes. So this one works. So if I start thinking about what happened here, I can think about finding slope. I mean, we could end up finding slope for any points that are crossing. Let's say I went with, let's just do these because they're in the positive. So if I started at one of them, I did my slope, rise over run. So if I was here, I'd go 1, 2, 3, 4, 5 up, and 1 over. So my slope was 5. Okay, that might be something I'm going to end up using here in a second. So it's something that's interesting, but I'm graphing on here. I'm able to graph because I put the position with here. I want to look at something before I go on. All right. Functions. Notice that the points plotted in example 2 appear to lie on a line. So that's this one, right? Yeah, they're saying, notice how these lie on the line. In fact, an arithmetic sequence is a linear function. You can think of the common difference d as the slope, and that 1 and a1 as the point to graph on the function. Remember, 1 is going to be talking about that's our first term, and then a1 what that was. An equation for point slope form for the function is an minus a1 equals d times n minus 1. Or it can be rewritten as an equals a1 plus n minus 1 d. Now, hearing that, you're probably like, ooh, Alrighty then. It's actually not confused. It's not that hard once you start using it. So, we'll end up putting this on our spiral later. This is the part that you don't have in yours that I found that I thought this clarified it for me. So this is, my goal is I'm going to print this off for you guys, and then we're going to cut them out and put it in our spiral notebook. But this is a better explanation for me. I found this helps me out. It says the nth term of a rhythmic sequence with the first term A1 and common difference D is given by that equation. Mainly when I look at this one, so when I have this equation, it tells me that the AN stands for the nth term. And we say nth term because we don't know. Remember how before I said, what if I want to know the 56th term? Are you really going to go out and work 56 times? No. But that's where, if I was to do this, I'd be able to write 56 here. So AN is whatever I'm asking you to find, the 56th term. Or if I say, I want to know what the 2057th term is, you would write that in for AN. A is the first term of the sequence. And then you do N. So let's say I said the 57th term, you do 57 minus 1. And then times our common difference, or whatever our constant rate is, our slope was going to be. Still sounds a little confusing, but once we try and apply it, it makes a little more sense. So that's why we do our homework. Write a rule for the nth term of the sequence. So they give us our sequence. What we are going to do is apply this equation. A plus n minus 1 times b. Alright, since I wrote it, I'm going to scroll up now. They're asking me here to find out in this sequence, when I go -4, 1, 6, 11, 16, let's find out what's the difference. What's the pattern happening right now? What would be the next number? After 16, what would come next? Grace? 21. And how did you get that?
Because I looked at the numbers and something was adding 5.
Our pattern's adding 5. -4 plus 5 is 1. 1 plus 5 is 6. 6 plus 5 is 11. So our pattern is adding 5, or our constant rate is 5. And now they said, hey, for any purpose, whatever they need to know, for some reason they need to know what the 100th term is. And instead of going, okay, I'm going to add 5 to 16 is 21, then 5, then 5, then 5. Instead of doing that, we're going to put this in. So I want to know the 100th term. Instead of AN, we write 100. A was our first term, -4 plus, in parentheses, N. We're asked to find the 100th term, so N is our 100. We're going to subtract 1, and then we multiply it by whatever our rate of change was, which was 5. That's the hardest thing you had to do. The rest of it is going to be PEMDAS. Okay, we got a question on this. What?
No. I was just wondering how, why that A before the plus sign equals -4. Yeah, that's my question. And the AN.
Okay, so the AN, remember, AN stands for, if you look up here, which term am I looking for? So because I said I want to know what the 100th term is, AN becomes 100. A is the first term of the sequence. Our first term was -4. So we're going to put that first term in.
But why is AN and N the same thing?
Huh?
Why is, because AN and N are the same thing?
Oh, because the AN, A is standing for the term, and N is standing for which term are we looking for, the 100th. So it's the 100th term. Technically, you're saying that they should have wrote AN in there instead of just N. I get that. All right, so then we're going to solve. Now we're just using PEMDAS. I have to do my parentheses first. 99. So that's 99. So I still have 100 equals -4 plus 99 times 5. What comes next?
Multiplication.
Multiplication, good. Anyone have their calculator? 99 times 495. Or you could have just done 100 times 5, 500 minus the 5. Okay? I have 100 equals negative 4 plus. This would give me 491. We have 100 equals 491. What am I forgetting on here though? Oh, I'm okay. And then I feel like I forgot something. Okay. Oh! Throwing things. Because I don't have to write 100 in here. It's the 100th term. So I'm really solving for this. I was like, what is this looking wrong? I was like, I know my answer is 491. So it's saying the 100th term is my 100th term equaled 491. So if I was to be bored and I was to sit home and I just kept adding 5 to each term and I got the 100th one, I should have ended up on 491. Okay?
What's the point of the minus 1?
Because we already had the 1 term in there. We're going to go 100 terms and we'll be back up to minus 2. Sometimes I don't understand the whole thing, but it works. Alright, so your homework. Alright, so for tomorrow, couple things.